Assalamu alaikum wa rahmatullahi wa barakatuh. Hi everyone, this is Mr. Sheikh Hamid with you, math and mechanics teacher at STEM Kafr Sheikh High School. Our topic today is the principles of motion. We will try to understand what is the meaning of displacement, velocity, and acceleration, when they are positive, when they are negative, what is the meaning of speeding up or slowing down, and what is the meaning of we have positive gravity or negative, or the gravity is always positive or always negative. We will try to understand all of these concepts right now. The only way to define motion is by changing position. The question is changing position relative to what? Do you think that you feel like you are motionless right now? Of course you are not. You are moving at about 1000 miles per hour relative to the center of the earth, and the earth is hurtling about the sun over 66,000 miles per hour. To understand more examples, if a man walks inside a train, what is his velocity? Of course, according to what? Everything is relative. According to a fixed point on the train, or according to ground-based observer. Of course, according to a certain point on the train, it will notice the only velocity of the man, neglecting the velocity of the train because both of them has the velocity of the train. However, for the a ground-based observer, he will see that the man is more faster the train, of course, if the man is moving in the same direction of the train, because he has combined the two velocities, his velocity and the train. Let's start with a question. Who is faster in real life? A boy is running due to east with speed 2 meter per second, or another one is running with speed 2 meter per second due to west. Another question. A ball is dropped from a building of height 50 meter above the ground. If two persons noticed that the situation, one stays on the ground and the other one at a point of height 100 meter of the same building, do you think the time would be different from each other? Assume that the pole will reach the ground. Do you think that the observer, we have both of observers, someone will calculate the time will be different from the other? Do you think that? Of course, they are the same for both questions. The velocity of the boy 2 meter per second, it is the same as the other one, which is 2 meter per second, although one of going from the east, the other one to the west, because in real life the speed is the same. Velocity is different because velocity cares about the sign. So the first one will be 2 meter per second, the second one will be negative 2 meter per second. But in real life we are talking about speed. The same as for the ball which is dropped from the building. The observer will find the time is the same for another one, because the observer doesn't change the real situation. It just see it in another way. So everything is relative. When we say we have a position time graph, when we say the position is 0 or the position is 1, we must say according to what? The position is 0, so according to something. This something might be a house or a reference or an observer. So this graph illustrates that a man starts his movement from his home, so the position at the beginning of time is 0, and then moved away for a period of time at a constant velocity. So when the time is moving, the position is also moving, and the slope is constant, so we have a constant velocity. Of course, in mechanics, don't deal with the graph as if it is real motion. He is not moving in this direction. This is just data. So when the time equals 1, for example, the position equals 1 or 2, whatever. When the time equals 2, position equals 2. When the time equals 3, position will equal 3. So for this case, the velocity is constant. Position is positive because this is the positive direction of y-axis. This means that the object is in front or above the reference. For example, we have a house here and the body is moving in front of it, not behind the house. If it was moving behind the house, it will be downward. This will mean that the position is negative. And velocity is positive because, of course, slope of the position is the velocity, and it makes an acute angle with the positive direction of x-axis. So tan theta is positive, and as a result, velocity is positive. This means that the object moves in the direction of the reference, as if the house is looking in this case, in this way. So the person or the man is moving in the same direction of the house. Do you understand? Another example, we have a BT, and this one starting from a point away from the reference, which is a house. Then it reached the house at the end of the time. So it means that a man started his movement from some distance from his house and started approaching until he reached it at a constant speed. It is the same, okay? But this one starting from the house and moving with a constant velocity. The second one starting away from the house and moved with a constant velocity. The same. So it means that position is positive because in both cases, the man moved in front of the house. Y-axis is positive, so the position is positive. Object is in front of or above the reference, but velocity is negative. Velocity is negative because object moves in the opposite direction of the reference because the man went in this direction. Okay, we will see right now VT table values for two cases for a car moving from rest. The first case, we have time when equals 0, velocity equals 0. When time equal 1, velocity equal 5 meter per second. When time equal 2, velocity equal 10. When time equal 3, velocity equal 15. Of course, as you can see, that the car is speeding up. The speed is increasing. So motion is speeding up. For the other one, it is the same. Time equals 0, velocity equals 0, time equal 1, velocity equal -5. As I mentioned, that it means that to the west, for example, if I consider this one to the east, this one to the west, so the real value of speed is the same. So this value, it is the same as this value in real life, as if both cars are increasing their speed uniformly, the same for both of them. Do you understand? So this motion in real life, it is the same as this motion but in opposite direction. So both of them is speeding up but with different explain. For the first one, velocity is positive because these values are positive. Acceleration equal 5 because velocity is increasing by 5, so acceleration equal 5. So one of the ways to define the speeding up, when we say velocity is positive, acceleration is positive. To the other side, velocity is negative, as you can see, and acceleration is also negative because -5 became -10, became -15, so I'm decreasing by 5, so acceleration is negative. But the final resultant of these values give me this data that motion is speeding up. And both tables could represent only one car but two observers. To understand what I'm saying, I will consider I have a car is moving to the east, and this table and the other one has two observers. Both of them has its own direction to look. So one of them, it has positive velocity, so velocity is positive and the acceleration is positive. And the other one, the car is moving in the opposite direction of its direction. Do you understand? So velocity is negative because the car is moving in the opposite direction of this observer. So velocity is negative, and acceleration is also negative for this one because the motion is speeding up. When we say the motion is speeding up, it might be velocity positive, acceleration positive if we are in the same direction of the observer, or velocity is negative, acceleration is negative if we are in the opposite direction of the observer. Let's try to conclude the BT graph from the VT graph. The same example that we are dealing with, we have time, displacement. How to know these values? For example, when the time equals 0, velocity equals 0, and the same as for the displacement. After 1 second, the velocity became 5 meter per second. Of course, this is a cumulative velocity. It is not constant. It is increasing. And we can't say that the displacement will equal 5 by 1 because this is not a constant velocity. It is increasing. But it became 5 at the end of this period. So I can just take the average velocity. Average velocity, it will just divide 5 plus 0 over 2, which is 2.5, and multiply by time. 2.5 times 1 equal 2.5. To understand this one, try to look at the second value. The final point of velocity is 10. The initial one is 0. So the average will be 10 plus 0 over 2. So it will be 5. And the time equals 2. 5 times 2 equals 10. Do you understand? To make more understanding, the third velocity equals 15. So the average velocity after 10 seconds will be 15 plus 0 over 2. Of course, you studied average in algebra. 15 plus 0 over 2 equals 7.5 times 3 equals 22.5. The other one is the same but with negative because they have the same magnitude. So we can graph the VT for both of them at the same graph. The first one we have 0 and 0, 1 and 5, 2 and 10, 3 and 15. And for the other one it is the same but for the negative, as if the motion is reflected about x-axis. Do you understand? So this is speeding up and this is also speeding up. This is speeding up in the positive direction with positive velocity, positive acceleration. The other one, negative velocity, negative acceleration. To graph the time BT graph, of course, I will start with a positive motion. So 0 and 0, 1 and 2.5, it will be just like here. 2 and 10, 3 and 22.5. Of course, they are not at the same straight line, so it is represented by a curve. Speeding up curve. It is a convex, and convex means positive acceleration, and the motion is speeding up. If I try to present these values, it will be the same reflection. But please don't deal with this case as the position is behind the reference or in front of it, because I concluded BT from VT. VT doesn't give me where is the reference. So this graph is true. Speeding up could be behind the reference down. Do you understand? Just like what I'm doing. and speeding up in the negative direction could be upward. Do you understand? From here. To understand what I'm saying, we have the same VT graph that we are studying in positive values 0 and 0, 1 and 5, 2 and 10, 3 and 15. And I will show you two different cases will apply for this single table. We have a car is moving to the east, and we have an observer behind the car. Do you understand? So the car will move in the direction of the observer, and its velocity is increasing. So velocity is positive, acceleration is positive, it is speeding up, and it can be, according to my situation, in front of the observer. Do you understand? It is in front of it. Or another case, that the observer is a car is behind the observer, but it is moving at the same direction of the observer. Try to understand what I'm saying. The car is behind the observer, but it is moving in the same direction. So velocity is positive, and we said that both of them has the same values of the table. So acceleration is also positive. So it is speeding up, but position is negative because it is behind the reference. This is what I mean in the previous slide, that when he gave me velocity time graph, it could be behind the observer or in front of the observer. We don't know, and both are true for this one. Let's finish with our last example. Do you think that gravity is positive or negative? We have Earth in the first case, a pole here to the left is dropped for both of them, and the observer here is down. It is looking, the observer is at the Earth, just like everyone living on the Earth. Uh, all of us we can say that we are observers to the pole. Do you understand? Because we are on the Earth. However, for the second case, a satellite, for example, is observing the pole. Try to understand what is the difference between them. For the first case, or even the second case, motion is speeding up because the pole is dropped. The pole is moving vertically downward, so its speed is increasing. So the truth is that both of them, the motion is speeding up. But in the first case, the observer is looking in the opposite direction of the pole. Do you understand? The pole is moving downward and the observer is looking upward, so velocity is negative. But motion is speeding up, so acceleration, which is gravity, will be negative. And if we considered the reference or the observer in the sky as the satellite, so it will be in the same direction of the pole, so velocity will be positive and acceleration is positive. Some references, as in Egyptian curriculum, students see some changes in the solving problems that books deal with the gravity as positive, and they got confused between the gravity, is it positive or negative. You can solve with gravity is positive or negative according to your reference. If you are dealing with velocity is negative, so each value of the if you are dealing with acceleration is negative or gravity is negative, each velocity in your problem you must give it negative, because velocity is negative and acceleration is negative. And if you want to solve the problem with positive values, so you need to consider the reference is at the sky or at these situations that I mentioned, and you can easily solve it with all positive values for positive velocity or positive gravity. I hope that you understood our session today, and see you soon with other concepts. Thank you so much.